To pass subnetting on the CCNA exam using Doug's method, of subnetting. Step 1, memorize and write down. This is when you get into the test, okay? Now you have to click Start before you do this. The chart. Step 2, memorize and write down the powers of 2 up to 2 to the 15th. 3, memorize and write down the formula. 3 things. We're going to knock them off one at a time. First thing we're going to do is we're going to study the chart. So please pull that up at this time. It's a file that you just downloaded. It's called Doug's Subnetting Chart. Password to open the file is Doug Lab Cisco. And here it is. It's an eyeful, isn't it? I'm going to show you the portion that you need to copy and write down, and we're going to practice doing this, okay? I want to highlight it in red, the things that you need to write down. That. You do not need this. Rarely, if ever, will we have a discussion about 4 billion addresses, 2 to the 32nd. How high did I say you needed to go? This high. This is the portion that you need to write down. This middle portion, not so much. Let's do it. Pull up a blank sheet of paper. Get your handy-dandy pen or pencil. Remember, it's this really thick felt marker that they're going to give you, dry erase marker, okay? They're not very nice. So draw a line. With me? I'm going to draw a rectangle. Over here on the right, we'll start drawing horizontal lines. Now you're probably thinking, Doug, how many lines am I going to draw? I'm going to show you. I don't know about you, but I hate memorizing things. The nice part about memorizing this chart is there is a pattern. Do you recognize the pattern already? Powers of 2, but what else am I representing? I'm representing the value positions of binary, but what have I done? Usually they're like this. Usually they view like this, horizontal, right? From left to right, ones and zeros. Well, what did I do? I just flipped it on its side. Everybody see that? This has a name. From now on to the end of eternity, it's called our block size. From now on, forever, it's called our block size. Notice that I start at 2 here. I didn't start at 1. These are different values. This column is called my subnets column. It's also known as my networks. That number references how many subnets or how many networks I have per block size. This value times this value is always going to equal 256. Always. Why 256? It's an octet, right? All ones on equals what? 255. But what do I have to count? 0. So I'm including 0. With me? So if I cut this block size, divide this number by 2, what is that? 128. How many networks am I going to have with a block size of 128? 2. Because 128 plus 128 equals 256. How many networks with a block size of 64 am I going to have? 4. How many networks with a block size of 256 am I going to have? Or with a block size of 1? 256. This range right here is known as the 4th octet. It's the far right octet. Let's move over to the 3rd octet. What's this column called? Block size. For the 3rd octet, here are my block sizes. What am I creating here? My powers of 2, because I'm doubling. Yes? What's 32K, approximately, in powers of 2? 2 to the what? Nope, 15th. That's why I told you you had to go up to on the Cisco exam, okay? That's the largest block size they'll reference. Is it 32K? Is it rounded off? Is it okay to round off numbers in the test? What is the actual number? You gonna guess? Which is what? The second thing you do when you enter the test. Write down your powers of 2. Because who wants to double in your head up to 2 to the 15th? Are you wanting to do that? You're wanting to do that first, okay? What is the number? What is it? 32,768. It's an exact number. Is it important to know that exact number for your block size? Absolutely. And you'll see why in a minute. In the third octet, what is this column? Subnets, otherwise known as the number of networks. Guess what? They're the same numbers. This column and this column are the same, even though they're in the third octet, the fourth octet. This column is known as CIDR, classless interdomain routing. It's also known as your prefix. Here they are. Notice I didn't start with /0. Why? How come I didn't start with /0? It's reserved. All zeros is reserved. Wouldn't a /0 be all zeros? Say again? I have no idea what you're saying. Can you explain? Oh, you're talking about the physical layer, electrical, binary? It's not relevant to our discussion here. It's a good point. But from now until eternity, do not reference in your mind physical layer bits to what we're talking about, Dave. Deal? What am I doing? Just typing slashes and numbers. Do they mean anything? Or is this just a handy dandy exercise that I'm going through? What am I doing? They're not subnets. This is CIDR and prefix, not a subnet mask. Subnet mask implies decimal, doesn't it? CIDR and prefix implies what? Binary. Oh my gosh, what am I doing now? Why did I put first, second, third, and fourth here underneath these columns of prefixes? What is the /1? Come on, what's a /1? Isn't that a /1? One bit on, from left to right, /1. True? Here's a /2. So on. /3, /4, 5, 6, 7, 8, until I get to 8 ones in the first octet. True? 8 more ones in the second octet. 8 more ones in the third octet. 8 more ones in the fourth octet. Can you visualize that now? What have I done with the binary? All I've done is flipped it vertically instead of viewing it horizontally. Okay? That's all I've done with the chart. That's it. Now, Dave, let's talk about the subnet mask. When I say subnet mask, I'm talking what? Decimal. How did I figure those numbers? Here's how. I took that one right there. Okay. Then I added 64 to 128 to get 192. Then I added 32 to 192 to get 224. You see the pattern? What am I doing? Am I turning bits on and off? What's that in binary? How'd you know that? It's a value position that's on, right? So that equals this number right here. See how I converted it to decimal? So I turn this bit on now, right? It's a value position. 64 plus 128 equals what? 192. Right? I turn this value position on. I'm doing the same thing I did here, but I'm expressing it in decimal instead of binary. Is everybody okay? That's the chart. You need to practice drawing it from memory because this is the first thing you're going to do after you click Start. You're going to draw the chart, powers of 2, and finally the formula. We're good with powers of 2, right? 2 to the 1 equals 2, 2 to the 2 equals 4. We just double it up to 2 to the 15th. Thumbs up on that one? Let's talk about the formula. Any questions about the chart? Now, all I did with the other chart, just as a frame of reference, is complete the /32, all ones on, right, all the way through the first octet. But the reason I didn't include these is you don't need to use them on the Cisco exam. You only need to go up to 2 to the 15th here, okay? Do you have this up in soft copy? The Word document or the PDF? Print it. Subnetting formula. This week, what you're going to do is take Doug's subnetting IP address practice spreadsheet, and you're going to open it. Doug Lab Cisco, right? And it's going to randomly create a list of IPs and prefixes. I've actually concatenated a formula so that every time you open this spreadsheet, it'll generate a new random pattern. Your job is to print it out and identify the network address and the broadcast address for that IP and prefix. Clear on the homework? Okay. And you'll be thankful that you were diligent about it, because you'll really start to nail it and you'll be excited. So let's take my formula. And let's use this IP address. It happens to be the one that's in the formula. And our job, actually I'm going to make this a little bit higher. Put it here instead. Note that we no longer care about what class address we're working in. With CIDR, class means nothing. Nothing. What class address is it, just for reference? Do we care? No, we do not. How many ones are on for this IP? From left to right? 11, right? So 8 in the first octet and 3 in the second octet. True? Taking this number 11, I find that in my chart. Does this chart look familiar? We just drew it, didn't we? /11. I immediately go to the far right column to determine my block size. For step number 2, always go to the far right column. Let's back up. Step number 1 was I identified my IP address and network prefix, didn't I? I saw that my IP was this, and I saw that my prefix was this. I also see that my subnet mask, my decimal value, is this. Why? First octet is 8 bits on equals 255. Second octet, 3 bits on equals 224, because the /11 is 224. With me? Here's a visual of the binary, okay? We're on step 2, though. So we took our /11, and we determined that our block size is what, guys? 32. This number becomes very important. Step 3. Can't see it right now, but it's there. Step 3. Determine which octet you're working in. Which octet are we working in? We know that because of this right here, okay? Remember how we put octet 1, 2, 3, and 4? /11, the binary that we're working in is in the second octet, okay? So we underline that number. This is what you're going to do on the exam. We bring that number down. And we divide 107 by the block size. Is that equal? And some change, right? But essentially it equals 3. What do we do with the change? Do we worry about it? Never. You can just forget about the change, okay? All we care about is that value, that first value. So we take that value, 3. So far, so good, right? Next step. We take that value 3 and we multiply it times the block size. Is that equal? The chart, the random chart with the concatenated numbers that pops up that use your homework this week, says to find the network address. Guess what the network address is for this exercise? 70.96.0.0. Take this value. This is the next step. Add it to the block size. Is that equal? 128, right? I subtract 1. The reason I subtract 1 is the network and broadcast addresses are always reserved. Didn't we say that? Zeros and ones are always reserved. You got your chart printed out? Look in the bottom right corner. To find what? The usable hosts. Is 0 and is the network and broadcast usable as a host? Never. That's why I'm subtracting 1 here, okay? What's that equal? 127. Therefore, my broadcast address is 70.127.255.255. What octet are we working in? Second, right? What's 96 to 127? What block size is that? 32. If you count from 96 to 127, isn't that 32? Not sure you're getting where I'm going here. If you 96, 97, 98, 99, 100, keep counting, block size 32. Don't I stop at 127? You're still not following? because you have to count 96. If you count 96 as 1, when you finish counting to 32, what are you at? 127. Because it's a network address. What if it was 0 with a block size of 32? 0, 1, see how I counted 0 up to 31? That's a block size of 32. With me? Also notice that a network address is always an even number, and a broadcast address is always an odd number. When you get out in the field as a network engineer and someone says, oh, that's a broadcast address, and it's an even number, guess what? They're wrong. Because a network address is always an even number. Always. And a broadcast address is always an odd number. Now you're probably thinking, Doug, you're crazy. But let's look through the whole step again. Block size 32. Determine the second octet. 107 divided by 32, we said it was 3.34. 34 is some change, right? We disregard the remainder value, and we take the rounded value of 3. 3 times 32 is 96. Example, the network address is 709600. That makes the first available host 709601. Would you agree? Notice how for the network address, to the right of the network address, I always turn it off. The bits are off. They go to zeros. I take 96, add it to the block size, equals 128, minus 1 for the broadcast, equals 127. So my broadcast is 70, 127, 255, 255. For the broadcast, I turn all the ones on, okay? And the last available address is 254. Do you see why? 1 less than the broadcast. How big is that block? Do you have Doug's subnetting chart in front of you? Which octet are we in? So look at your block size column in the second octet. How many hosts do we have with a /11? How many hosts in a /11? Second octet. Look at your block size. Look to the left, find /11, right? If you're not seeing it, look up here at the overhead. If you're not seeing it, /11, right? Second octet. Didn't we say we're in the second octet because we're in a /11, right? How many hosts in a /11 network? That many. That's 2 to the what? This guy right here, isn't it? And do we care about the exact number? So it's 2,097,100 and what? 50. Why? Because you have to subtract 2 to get the number of usable hosts. 0 is reserved, so is the broadcast address. Now, you may be thinking, I just don't buy it, Doug. Well, click on this bad boy, this CIDR calculator over here. We'll bring up a website. It's a VLSM CIDR calculator. Notice it's not a subnet calculator because we're classless, right? We move our prefix up and down. We don't care about classful networks. What's our IP? 70. 107. 23. 22. How many bits? So I go down here to 11. Bing. Here's my CIDR. Notice my second octet is 96. My broadcast is 127, 255, 255. How many addresses do I have? 2,097,150. Remember how I said prefixes? Or prefixes for access lists? We also use wildcard masks for OSPF. You can also use them for EIGRP. 0.31.255.255 is the same thing as saying a /11, only it's backwards.